Third grade teachers, today we're going to take a look at Unit 2, Exploring Multiplication. The purpose of this video is to provide an overview of the standards, intended pacing, and sample instructional strategies. In Chapter 1, we are going to review the AKS and Indicators of Achievement, or IOAs, for Unit 2. The AKS is the overarching knowledge and skills that students are expected to master. The IOAs are the learning objectives that allow students to demonstrate mastery of the AKS. The AKS and IOAs may not be taught in their entirety the first time they appear on the instructional calendar. Some AKS and IOAs will appear multiple times throughout the year. In Chapter 2 of the video, we will look to see how the AKS and IOAs in this unit are paced in detail. Welcome to third grade Unit 2, Exploring Multiplication. This unit has 3 AKS. On these slides, you will see the AKS and the IOAs that support the AKS within this unit. Just as a reminder, at the end of each AKS and IOA in parentheses, you will also see that we have the state coding at the end, so that if you are looking up resources on the Georgia DOE website, you are able to find the IOA that is related to the GCPS IOA. Unit 2 is all about multiplication. Although AKS 3 refers to division, this unit is solely about multiplication. Division will be addressed in Unit 3. This unit begins with AKS 3, IOA 3A, where the focus is on patterns. Students will discover how patterns relate to multiplication. After recognizing and making connections between patterns and multiplication, students transition into learning about multiplication strategies. IOAs 3B, 3C, and 3F focus on these strategies. These strategies include equal groups, arrays, and properties. IOA 3D is new for third grade. This IOA is anchored in the meaning of the equal sign. In this IOA, students have to determine if expressions are equal to one another. Let's look at IOA 3H. This is where students engage in pictographs. This is the first time they will be doing this work. Pictographs will have scales or intervals greater than 1. This IOA is specific to Gwinnett, and because of this, you will not find the states coding in parentheses at the end of the IOA. However, you will find some resources for pictographs embedded within the Georgia DOE units and lessons. AKS 5 and IOA 5A are ones that will continue to appear in multiple units because they are not taught in isolation. 7 has 3 IOAs and 1 extension. The focus of this part of Unit 2 is area and how it connects to multiplication. IOAs 7A and 7B allow students to investigate the meaning of area and how a square unit is used to measure the attribute of area. IOA 7C is where students learn that area can be found by multiplying side lengths. In Unit 3, students will explore the relationship between multiplication and division, and this is where students will explore missing side lengths. IOA 7D is an extension IOA. The new extension IOAs are there to support the differentiated needs for students. As you can see, the word extension is bolded and in parentheses. This is to notify you that they are extensions and are specific to Gwinnett County. Please note you will not find resources from the state for these IOAs, nor will they be pasted on the pacing guide. Chapter 2, Unit Pacing. Our pacing guide is closely aligned with the state pacing. With the first year of new standards, we want to ensure we are following the expectations from the state. The pacing guide is an example intended to model how instruction of the AKS and IOAs in each unit may be facilitated, but teachers should design pacing to be responsive to the learning needs of their students. Let's head over to ECOM, the Elementary Communication Center, to find our Quarter 1 pacing guide. Here we are on the 3rd grade math unit page. Here, the units taught throughout the school year are linked. Let's click into Unit 2, Exploring Multiplication. Here you will see on our unit page for the Exploring Multiplication unit, the AKS we reviewed in Chapter 1. Scroll down below the AKS and you will find a link to the pacing guide. Click here for the Quarter 1 pacing guide. In this box, on the pacing guide, you will see the unit name, which is Exploring Multiplication, and a suggested pacing. For Unit 2, we suggest 5.5 weeks. The big ideas for the unit are included, as well as any links we feel would be beneficial for the entire unit. This link is a link to Thinking Strategies for Multiplication Facts. This document provides instructional strategies which can be used for AKS 3 as students learn their multiplication facts. The IOAs have been grouped into 3 parts. There is a focus on patterns and multiplication strategies, then area, and finally, pictographs. Pacing guide is set up with a list of the AKS and the IOAs, which have been strategically clustered together. This is followed by our suggested pacing. In the left column, you will find the learning progressions for the IOA and the AKS. These learning progressions include the concrete, representational, abstract progression, as well as the progression between specific learning targets. Suggested manipulatives are also listed in this column. In the right column, you will find resources to support and guide your instruction. You will find resources such as GCPS traditional lessons, task-based lessons, Georgia DOE lessons and activities, as well as lessons from Georgia Reveal, our newly adopted resource. As you can see, we will begin Unit 2 with patterns. This unit will begin with a task-based learning lesson to support students in discovering numerical patterns. The Patterning IOA 3A is intentionally embedded throughout the unit so that students make connections between multiplication and patterns. After exploring patterns, students learn to represent multiplication using equal groups, arrays, and skip counting. You will also notice IOAs 3B and 3F are clustered throughout this part of the unit. This is because practical and relevant problems are used as students learn to represent multiplication. Here is an example of a Georgia Reveal lesson being used to support instruction with arrays. You will also notice on the pacing guide, there are specific lessons that teach multiplication thinking strategies. For example, here's a lesson on the half then double strategy, as well as a lesson on the add a group multiplication strategy. Students will also explore the commutative property, the associative property, and the distributive property. These properties support the development of fact fluency with our students. The last part of Unit 2 is anchored in area and pictographs. The concept of area kicks off with a concrete investigation into what is a square unit as well as tiling rectangles. Students then transition into the representational learning phase of this IOA, where they begin to draw rectangles to represent their arrays, to find area, and eventually progress to multiplying side lengths to find the total area. Students will also use the distributive property to find area when side lengths are larger numbers. And lastly, students engage in IOA 3H, where they work with pictographs for the first time. Chapter 3, Instructional Strategies. This portion of the video will highlight specific instructional strategies that will be utilized within Unit 2. Please refer to the Analyzing the Standards document for guidance on additional instructional strategies for each IOA. Our grade teachers, today we're going to take a look at a problem for IOA 3A. This is connected to AKS 3, our multiplication and division AKS. IOA 3 sets the expectation for students that they are to describe, extend, and create numerical patterns related to multiplication. They are also to make predictions related to these patterns. Let's take a look at the problem we have here. It says choose either 2, 3, or 4 to explore, create, and describe a numerical pattern using the hundreds chart. As we get into this, you do have a hundreds chart in your classroom through your manipulatives that you can use. It's laminated. Your students can use it with an expo marker to highlight patterns on here as well. But for our purposes today, we are going to use the one that's been printed on our problem here. Okay, so let's jump right in and start talking through this problem. With this problem, we have to choose either 2, 3, or 4 to explore, create, and describe a numerical pattern. I'm going to choose the number 4. All right. This is going to be the number I am going to explore to explore the numerical pattern for 4s. I'm going to start with 0. And I'm going to skip count by 4 each time and highlight the numbers, okay? For scaffolding purposes, you may want to have your students write a 0 in front of a 1 or put a counter in front of the 1. If you are using the hundreds chart, you could put a counter right here if you needed to. This will help scaffold them with their counting and one-to-one correspondence to ensure that they land on the first number in the counting sequence as being 4. For example, we would start with 0, 1, 2, 3, 4. We made a jump of 4. And my first number in my counting sequence will be 4. If I count 4 more, 1, 2, 3, 4, the next number in my counting sequence is 8. And I'm going to continue that. 1, 2, 3, 4. There's 12. And I'm going to go ahead and highlight, skip count the numbers that are in the counting sequence when we skip count by 4s. 32, 36, and 40. For our purposes today, I'm just going to stop at 40, but your students would continue shading in all the numbers in the counting sequence when you count on or add 4 each time until you get down till you cannot complete, till you get to the end of the hundreds chart, okay? All right. So once the students have highlighted the numerical patterns on the hundreds chart, I would have them write the multiples out horizontally so that they can begin recognizing some of the patterns that they're seeing that are highlighted in the hundreds chart as well as in the horizontal counting sequence. Okay, I am going to start with, actually, I'm going to start with 0. Then the next number is 4. And then it is 8. And then we have 12, 16, 20, 24, 28, 32, 36, and 40. Okay. Here, I can go ahead and start discovering and making some noticings about the patterns that I have just highlighted in my hundreds chart, as well as can see down in my horizontal counting sequence. What I notice is that all of the highlighted numbers are even numbers. So I'm going to jot that down right here. My highlighted, and I'm going to use the abbreviation for numbers. Highlighted numbers are even. Okay. And the other thing that I noticed, and that hopefully students will, after counting through and adding 4 each time, that they will recognize, each time the counting sequence increases by 4. Okay. So what we did, we added 4 each time to find the next number in our counting sequence. Okay. Sometimes it's difficult. This can be limiting when you just see the numbers here on the hundreds chart or when they're written or horizontally. Sometimes it's helpful to put them in a vertical T-chart, and I'm going to do that here. And I'm going to divide my T-chart into 10s and 1s. And then I'm going to record the numbers I recorded in my horizontal counting sequence here vertically. Okay, I'm going to start here. Since I have 0 as my first number in my counting sequence, I'm just going to go ahead and list it here because it will help me discover and dig into those patterns as we keep going. Then I'm going to write 0, 4, because there are 0, 10s, and 4, and 0, 10s, and 8 1s. And then I have 1 10, 2 1s for 12, 16, 20, 24, 28, 32, running out of room, 36, and then 40. Your kids would obviously continue this counting pattern because they would have completed the entire hundreds chart. But when I look, now that the numbers are written this way, I can see that there are other patterns here that I didn't recognize when they were just here on the hundreds chart or written horizontally. Okay. I can clearly see that in the 1s place, the core pattern is 04826, and then it repeats. That is very clear with what's happening here. You can see it again, 04826, and then it continues to repeat. So that's a discovery that we just made by looking at the counting sequence when it's in a vertical key chart. So another noticing we have is the core pattern in the ones place is 0, 4, 8, 2, and 6. And it's that 0, 4, 8, 2, 6. That is the counting sequence. That is the order of those numbers. And you can talk up with your kids about, wow, that's pretty interesting that we went 0, 4, 8 and then went back to 2. Oftentimes students will think as you count, the numbers will increase in the ones place, but it's very interesting to see how the patterns behave here. The other thing, when I look at this, I see that my digits repeat over here in the tens column. But what I'm really noticing is I have 3 zeros, 1, 2, 3, and then I have 2 ones in the tens place, 1, 2, 3 twos, and then 2 threes, and then I have 1 4. And when we come back to making predictions here relating to the pattern, I would have my students predict how many 4s do they predict would be in the tens column if they were to continue the counting sequence. And there should be 4. What I did notice is that whenever there's a 0, 4, or 8 in the ones place, that's where the repeat of the 10 of the multiple, the tens place repeats 3 times. And whenever there's a 2 or a 6, the tens place repeats twice. So we did notice, I know I got further into detail here, but one of our noticing is that the tens column has digits that repeat, and you can have your students dig into this a lot more. Let me move this up so you all can see it. I apologize about that. Tens column has digits that repeat. And these are questions as you push into your groups and ask your students about. I would have them explain, well, why is that? Why do you think that's true? Ask them about those predicting, what they predict the pattern will be next. Okay. So discovering these patterns will support students as they begin to dig into their work with multiplication. And like I said initially, students should make connections that in order to find the next number in the counting sequence, they're adding 4 each time, which directly connects to repeated addition. You will have to be explicit in making those connections with the repeated addition. And oh my gosh, we're adding 4 each time. That's just like repeated addition when you get there with your multiplication strategies. But one thing I do want to point out is what I just modeled here for you today is from the first multiplication task-based lesson for IOA 3. It is your very first lesson. Your students will create these charts and make discoveries on their own in regards to the counting patterns that you have assigned to your student groups. But the bigger idea here is that these discoveries and the charts your students are going to make, they can serve as your class anchor charts as your kids begin engaging in the operation of multiplication. For example, as you encounter, you and your kids encounter multiplication problems that have a factor of 4, come back to this chart and remind students that the product of a problem that has 4 as a factor has to have either a 0, a 4, an 8, a 2, or a 6 in their product. That will be helpful for them to reason through and determine if the product they got is actually reasonable. Hopefully this has helped you kind of think through what is happening with our IOA 3. And again, for more instructional strategies that you will use with your students, you can go back to our Analyzing the Standards document. Hi, third grade teachers. Today we are going to take a look at a problem for AKS 3, our multiplication AKS, and the IOAs that relate to it, specifically 3B, 3C, 3D, and 3F. IOA 3F, solve practical relevant problems involving multiplication and division, is always embedded in the work we do with multiplication and division. Today we're going to focus on multiplication strategies, the variety of strategies students will use, as well as the how to use properties as strategies as well. And towards the end of our video, we are going to dig into 3D, where students determine whether expressions involving addition, subtraction, and multiplication are equivalent to one another. So let's go ahead and jump into our problem. A tennis coach has 7 cans of tennis balls in a basket for her players. Each can, has 3 tennis balls in it. How many tennis balls are in the basket? Well, when I introduce problems to my students, I always have them visualize what's happening in this problem. I call it a math movie. What math movie do you see happening when you think about this problem? And I model my thinking for my kids and explain, well, I can clearly see a coach dump the opening 7 cans of tennis balls and dumping them in the basket for her players. And there in each can, there's the same amount. There are 3 tennis balls in each. And I see a whole basket at the end filled with tennis balls. And what the question is asking me, how many tennis balls are in the basket? That means I've got to figure out how many there were altogether. To organize my thinking around this problem, I'm going to use use my part-whole thinking, and I'm going to organize that into a model that will represent, hopefully, what I'm visualizing. This rectangle, I'm going to partition into 7 groups because of my 7 cans of tennis balls. So 1 group, 2 groups, 3 groups, 4 groups, 5 groups, 6 groups, and 7 groups. So I have my 7 groups of my 7 cans of tennis balls, and I know in each can, there are 3 tennis balls in it. So I know in each one of these groups I've created, I can write the number 3. That tells me each group has the exact same number. They are equal groups. That's an important concept for multiplication with students. But what I don't know here is my question. How many tennis balls are in the basket? Well, I don't know what my total is here. So this is my model, and it does represent what's happening in my problem here. Using my model, I can write the equation I'm going to use to solve this problem. And I know that there are 7 groups of 3. So I can use, there are 7 groups. The multiplication sign means nothing more than groups of 7 groups of 3 equals an unknown amount. That is my product. That is what I do not know. Okay. As students engage and begin representing multiplication facts, they will begin using all different strategies. They will use equal groups. They will use arrays. They will connect repeated addition to those equal groups and arrays. They will also begin skip counting by making equal jumps on a number line. Okay. And as with any brand new concept, best practices is to start with that concrete phase of learning. So let's kind of jump into this and think about what's going on here with our problem in regards in using the equal group strategy. Okay. I'm going to make some adjustments here with my camera so that we can see everything that's going to be going on. So I know I need to make some equal groups. I need 7 equal groups of 3 in each group. I have some counters. I have 1 group of 3. I have another group of 3, 2 groups of 3, 4 groups of 3, 5 groups of 3, 6 groups of 3, and here's my 7 groups of 3. So I can clearly see my equal groups here. In each group, there's 3. I can connect repeated addition with this model. So my students, and it's clearly shown in this model as well, the repeated addition equation that represents the equal group model is 3 plus 3 plus 3 plus 3 plus 3. There's 5 groups of 3, 6 groups of 3, and lastly, 7 groups of 3. 1, 2, 3, 4, 5, 6, 7. Yep, I have 7 groups of 3, and that is represented here as well. Your students, when they begin engaging in these strategies, will count all because they haven't developed efficient strategies to think about how to unitize yet and think more abstractly about that. So they would count all and find that there are 21 tennis balls with this model, okay? The next strategy your students will engage in, and I'm going to slide these equal groups out of the way a little bit, is the array strategy. The array strategy also represents equal groups, but it's done with rows. And I can do this. I already have put together for us. Back out my camera a little bit so you can see everything. I intentionally built my array with 1 color tile stacked vertically. Each color tile represents my 7 cans or my 7 groups. 1, 2, 3, 4, 5, 6, 7. And in each of these groups in each of these rows in my array, I need to make sure there are 3 color tiles because there are 7 groups of 3, and we have that in our model here. So I'm going to magically pull up my array that I've put together, and I have just that. I have my 7 groups, and in each of my 7 groups, there are 3 color tiles. 1, 2, 3, 3, 3, 3. What you will make connections to for your children is that the repeated addition is still the same for the array model. We have 3 plus 3 plus 3 plus 3 plus 3 plus 3 plus 3. Again, they will count all because of where they are it's a brand new concept for them. So they will count all and determine that, yes, there are 21 tennis balls in the basket. So we have determined 21 tennis balls are in the basket with both the equal group strategy and our array strategy. Another strategy I wanted to show you that your kids will engage in is the skip counting strategy on the number line. Since we have 7 groups of 3 on the number line, your students will make jumps of 3 7 times on a number line. And hopefully we will land at 21. To do that, your students will just draw their number line. We will begin at 0. That's where our first jump will come from. And when we add 3 to 0, we get 3. And then when we add another group of 3, we get 6. Another group of 3 is 9. Another group of 3 is 12. Another group of 3 is 15. The 6th group of 3 gives us 18. And that 7th group of 3, we're adding 3 7 times, gives us a total of 21. So we have solved this problem using 3 different strategies: the equal group strategy, the array strategy, as well as the skip counting strategy on a number line. Those are all initial strategies your students will engage in to establish the meaning of multiplication and learn how to represent it. But what I want us to think about today is how we can use our properties, the IOA 3C, as a strategy, as a multiplication strategy, specifically the distributive property here. That's what we're going to focus on. The distributive property is a strategy that's most helpful when dealing with challenging factors such as 7 in this problem. And when we introduce this property as a strategy, we will always do it concretely. So let's go ahead and go back to our original array that we built here when we found all, the students counted all, they repeatedly add, maybe they grouped the 3s to find the total of 21, that we're going to think through the lens of the distributive property. And I'm going to slide that equal group up out of the way. And I'm going to pull this down and we're going to talk this through a little bit. All right. Okay. So as your students become more sophisticated with their thinking and they're learning about the strategies, we will have to model for the thinking for them to know when it's best to apply the properties. Okay. I always tell my kids, when I see a factor that gives me trouble, I always want to decompose it into factors that I know that are easy for me to solve. For example, with this 7, when I see that factor of 7, I know that 5 and 2 make 7. So what that means is I can come over to my array and I can decompose this group of 7 into a group, 2 groups of 3, and then that leaves me with 5 groups of 3. There's 1 group of 3, 2 groups of 3, and then 1, 2, 3, 4, 5 groups of 3 in this array. All we have done is decompose 7 into friendlier numbers to make our problem easier to solve. So what we have here is 2 groups of 3, and I know 2 groups of 3 is 6, and that's because whenever I see 2 as a factor, I know I can just double this other factor, and I can clearly see the double here, 3 plus 3. So 2 times 3 is 6. Okay, I'll tip my camera a little bit to help see us get a better perspective of what's going on here. And then when I look down at this array that I decomposed, I just broke it apart, right? I have 5 times 3. And I know my 5 facts pretty well. I can skip count by 5 3 times, 5, 10, 15. You'll see your kids count on their fingers. So that gives me 15. All right. And what I know about this is that because I decompose this array, I have to put it back together again, which means I have to add these partial products together to find the total. So I know, I'm going to slide this over a little bit, that 6 plus 15, 6 and 5 is 11, plus that other 10, which gives me 21. Okay. Slide that over so you can see it. Sorry about that. All right. So going back to this, we have decomposed our original array because 7 was a very challenging factor. We decomposed it using the distributive property. We found each partial product and we composed it back together. We put it back together to find a total of 21. Well, we found 21 tennis balls were in the basket with our equal groups. We found it with our original array. And we also found there were 21 baskets using our number line. Okay. That is that's a lot of learning going on right here. Now what I want us to transition into and think about is, how is this IOA of 3D use the meaning of the equal sign to determine whether expressions involving addition, subtraction, and multiplication are equivalent? How is this IOA embedded into this work we did specifically with the distributive property? This is where you will find IOA 3D embedded into 3C right there. Okay, let's talk that through. So this IOA is anchored in determining equivalency of expressions involving addition, subtraction, and multiplication on either side of the equal sign. It is going to be imperative that as teachers, we read the equal sign as the same as, okay? This expression, for example, we would say this expression has the same value as this expression, and we're going to talk that through. Let's go back to our decomposed array here. I'm going to write an equivalent equation using our original expression as well as what we've done over here, okay? And so to do that, I'm going to start, actually, I'm going to use this. Our original equation was 7 times 3. Based on what we did here, we decomposed this 7 into 2 plus 5. That's all we did. So we could say 7 times 3 is the same as 2 plus 5 times 3. Because what we're going to have to do now, and what we did over here, we had to multiply both of our add-ins times 3, because in each one of these groups was 3, okay, groups of 3. So when we transition to the next part of our equation to show what we did over here, we will write 7 times 3 is the same or has the same value as 2 times 3, and we can clearly see that right here, plus 5 times 3. And we use the addition sign here because originally we decomposed this, but we have to put the partial products back together to find our total product. That's why we put the plus sign here, the addition sign, okay? So now that we have this, we have proved that 7 times 3, it is 21. We've proved it with our equal groups, our original array, our skip counting, and we're just rewriting it in a different way at a more abstract level than where we originally started with this. So the next part of this would be 7 times 3 has the same value or is the same as, and I'm going to go ahead and solve these just like we did over here. 2 times 3 is 6, plus 5 times 3 is 15. So 7 times 3 has the same value as 6 plus 15. Okay, they are the same, which leads us and brings us all the way back to our original equation. 7 times 3 is the same as 21. This IOA is going to be important for our students to engage in, and it's going to be important for them to develop an understanding that the answer is not always going to be just as they've always seen it, a 2 or 3 digit number, or a 2-digit number in our case when multiplying within 100. Our equations can be written to show equivalency in different ways, and that's what we've done here, okay? Hopefully this has helped you connect how all of these IOAs go together. Again, don't forget your Analyzing the Standard document is a tremendous resource for you to go back and refer to as you get further into your multiplication unit.
So, which strategy? In mathematics, the emphasis is on the reasoning and thinking about the quantities within mathematical contexts. Specific mathematics strategies for teaching and learning are not mandated by the Georgia Department of Education or assessed on state or federally mandated tests. Students may solve problems in different ways and have the flexibility to choose a mathematical strategy that allows them to make sense of and strategically solve problems using efficient methods that are most comfortable for and make sense to them. It is critical that teachers and parents remain partners to help each child grow to become a mathematically literate citizen. These standards preserve and affirm local control and flexibility. This is from the Georgia DOE's Comprehensive Grade Level Overview. Thanks again. We appreciate you watching.